This course is based on Safety in Retaining Wall by Ankush Halkar. Myself Ankush Halkar. I will teach you this learning program. What is retaining wall? Second, parts of retaining wall, types of retaining wall. Fourth, earth pressure. Fifth, safety in retaining wall. What is retaining wall? A retaining wall is a structure built to support and hold back soil or other materials on one side while allowing for a change in elevation or slope on the other side. Retaining walls are commonly used in landscaping, civil engineering and construction to prevent erosion, manage water runoff, create level areas on sloping terrain and stabilize embankments. Second, retaining walls come in various designs and materials, depending on their purpose, the height of the wall, the type of soil or material being retained, and aesthetic preferences. Some common types of retaining walls include gravity retaining wall. These walls rely on their own weight and mass to resist the lateral pressure exerted by the retained soil. They are typically made of heavy materials like concrete or stone and do not require mortar or reinforcement. Second, cantilever retaining wall. Cantilever walls are designed with a vertical stem and a horizontal base or footing. They use the leverage principle to counteract the pressure from the retained material. They are often made of reinforced concrete. Counterfort retaining wall. Similar to cantilever walls, counterfort walls have vertical stems and horizontal bases, but they also have regularly spaced vertical support columns or buttress on the rear side of the wall, which provide additional stability. Second, reinforcement soil retaining wall RSRW. These walls use layer of geosynthetic reinforcement materials such as geogrids or geotextiles within the soil to improve its tensile strength. RSRW are often used in applications like retaining walls or highway embankments. Gypsum retaining wall. Gypsum walls are constructed using wire mesh boxes filled with stones or rocks. They are a flexible and permeable option for retaining walls and are commonly used in landscaping and erosion control. Second, segmental retaining wall SRW. SRWs are modular system made of precast concrete blocks or units that interlock to create a stable wall. They are popular in residential landscaping projects due to their ease of installation and aesthetic options. Retaining walls are essentially for preventing soil erosion, maintaining the integrity of structures, and creating usable spaces in areas with uneven terrain. Proper design and construction are crucial to ensure the safety and effectiveness of retaining walls, especially for walls that will be supporting significant loads or located in areas prone to soil movement. Consulting with a structural engineer or a professional with expertise in retaining wall design is often necessary to ensure a reliable and long-lasting solutions. All permanent walls and components shall be designed for a minimum service life of 75 years. Erosion protection is required for all permanent and temporary walls in aggressive environments. Retaining walls are usually built to hold back soil mass. Second, they are also provided to maintain the ground at two different levels. Types of retaining walls: gravity retaining walls, semi-gravity retaining walls, cantilever retaining walls, counterfort retaining walls. Gravity walls. The gravity wall provides stability by virtue of its own weight and therefore is rather massive in size. It is usually built in stone masonry and occasionally in plain concrete. The thickness of wall is also governed by need to eliminate or limit the resulting tensile stress to its permissible limit. Plain concrete gravity walls are not used for heights exceeding about 3 meters for obvious economic reasons. Safety in retaining wall. Safety in utmost importance when designing, constructing and maintaining retaining walls. Retaining walls are structured but built to hold back soil or other materials and prevent erosion or collapse. Ensuring their safety is critical to protect property and people. Here are some key considerations for safety in retaining wall design and construction. Stress developed is very low. These walls are so proportioned that no tension is developed anywhere and the resultant forces remain within the middle third of the base. Semi-gravity walls. Semi-gravity walls resist external forces by the combined actions of self-weight, weight of soil above footing, and flexural resistance of the wall components. Concrete cantilever wall is an example and consists of a reinforced concrete stem and a base footing. These walls are non-proprietary. The cantilever wall is the most common type of retaining structure and is generally economical for heights up to 8 meters. The structure consists of vertical stem and a base slab made up of two distinct regions, a heel slab and a toe slab. Stem acts as a vertical cantilever under the lateral and earth pressure. Heel slab acts as a horizontal cantilever under the action of weight of the retained earth bracket minus soil pressure acting upward from below. Toe slab acts as a cantilever under the action of resulting soil pressure acting upward. It resists the horizontal earth pressure as well as other vertical pressure by way of bending of various components acting as cantilevers. It may be L-shaped or T-shaped. Stem and heel slab are strengthened by providing counterfort at some suitable intervals. The stability of the wall is maintained essentially by the weight of the earth on the heel slab plus the self weight of the structure. For large heights in a cantilever retaining wall, the bending moments developed in the stem heel slab and the toe slab become very large and require large thickness. The bending moments can be considerably reduced by introducing transverse supports called counterforts. Counterfort walls are placed at regular intervals of about 1/3 to half of the wall height, interconnecting the stem with the heel slab. The counterforts are concealed within the retained earth on the rear side of the wall. The wall is economical for height above approximately 7 meters. The counterforts subdivided the vertical slab stem into rectangular panels and support them on two sides super suspender style and themselves behave essentially as vertical cantilever beams of T-section and varying depth. Earth pressure. Earth pressure refers to the force exerted by soil or other earth materials against a retaining structure such as a retaining wall or a sheet pile. Understanding earth pressure is essential in the design and analysis of these structures to ensure they can safely withstand the lateral forces exerted by the surrounding soil. There are three primary types of earth pressure. Lateral earth pressure. Lateral earth pressure is the horizontal force exerted by the soil against a retaining structure. It can be further classified into three common types. Active earth pressure. Second, active earth pressure is the horizontal force exerted by the soil when it is trying to push the retaining structure away from it. This occurs when the soil mass is free to move and is in a state of potential failure, such as when the soil is pushed outward. Third, passive earth pressure. Passive earth pressure is the horizontal force exerted by the soil when it is trying to prevent the retaining structure from moving toward it. This occurs when the soil is resisting the movement of the wall into it. At the rest earth pressure. At rest pressure is the horizontal force exerted by the soil when it is in a state of equilibrium, neither pushing the wall away nor resisting movement toward it. It represents an intermediate condition between active and passive pressures. Vertical earth pressures. Vertical earth pressure is the force exerted by the soil above retaining structure in the vertical direction. It is important in calculating the bearing capacity of the foundation and ensuring that the foundation can support the weight of the soil above it. Second, horizontal earth pressure. Horizontal earth pressure is the force exerted by the soil in the horizontal direction but not necessarily perpendicular to the retaining structure. It can be caused by various factors such as surcharge loads, adjacent structure, or sloping ground. Properly understanding and accounting for earth pressure is crucial in the design and construction of retaining walls, dams, excavation support system, and other geotechnical engineering projects to prevent structural failure and ensure long-term stability. The magnitude and distribution of the earth pressure depend on several factors, including the type of soil, its density, the angle of internal friction, the angle of repose, the depth of the wall or structure, and the wall's design. Engineers use various theories and methods such as Rankine's theory, Coulomb's theory, and Tarjahi-Weigmann theory to calculate and analyze earth pressure to ensure the stability and safety of retaining structures. Earth pressure, pressure at rest, active earth pressure, passive earth pressure. Pressure at rest, when the soil behind the wall is prevented from lateral movement toward or away from the soil or wall, the pressure is known as earth pressure at rest. This is the case when the wall has considerably rigid. Basement walls generally fall in this category. Active earth pressure, if a retaining wall is allowed to move away from the soil accompanied by lateral soil expansion, the earth pressure decreases with the increasing expansion. A shear failure of the soil is resulted with any further expansion, and a sliding wedge tends to move forward and downward. The earth pressure associated with this state of failure is the minimum pressure and is known as active earth pressure. Passive earth pressure, if a retaining wall is allowed to move towards the soil accompanied by a lateral soil compression, the earth pressure increases with the increasing compression in the soil. Safety in retaining wall. Safety is the critical concern when it comes to retaining walls. Retaining walls are the structure designed to hold back soil or other materials to prevent erosion, landslides, or to create level ground for landscaping or construction. Ensuring their safety is crucial to protect people and property. Here are some key safety considerations for retaining walls. Number 1, proper engineering. Retaining walls should be designed by a qualified structural engineer who considered factors such as soil type, wall height, load bearing capacity. Local climate conditions, engineering calculations ensure the wall can safely support the intended load. Material selection. Choose appropriate materials for the retaining wall such as concrete blocks, treated timbers, natural stone. Based on the site specific requirements, ensure that the chosen material meet local building codes and standards. Foundation. A solid foundation is crucial for the stability of the retaining wall. Proper excavation, compaction, and the use of appropriate base materials are essential to prevent setting or tilting. Rearrangement of particle after consolidation. Drainage. Poor drainage can lead to water buildup behind the wall, increasing the pressure on it and potentially causing failure. Including drainage solutions like weep holes, gravel backfill, or drainage pipes in the design. Backfill. The type and compaction of the backfill material are vital. Use granular material that drain well and compact properly to minimize the pressure on the wall. Terracing. For taller walls, considering terracing with multiple shorter walls, or using reinforced retaining wall system to distribute the load and to reduce the risk of failure. Reinforcement. Reinforcement is the context of construction and engineering, refers to the use of materials or structural element to enhance the strength, stability, and performance of a structure or component. Reinforcement is commonly employed to resist various forces and stress, improve durability, and extend the lifespan of structure. These are several types of reinforcement used in construction. Number 1, steel reinforcement. Steel reinforcement, typically in the form of steel bars or wire mesh, is widely used in reinforced concrete structure. Concrete has high compressive strength but relatively low tensile strength. By adding steel reinforcement, The composite materials become capable of withstanding both compression and tension forces, making it suitable for various applications like building, bridges, and foundations. Second, fiber reinforcement. Fiber reinforcement involves adding small fibers such as steel, glass, or synthetic fibers to concrete or other construction materials. These fibers enhance the material's property by increasing tensile strength, improving crack resistance, and reducing shrinkage, cracking. Fiber reinforcement concrete (FRC) is often used in material floors, pavements, and precast products. Third, masonry reinforcement. In masonry construction, reinforcing elements like metal ties, anchors, and connectors are used to strengthen and the bond between masonry units, enhance lateral stability, and resist forces like wind, seismic loads, and thermal expansion. Fourth, geosynthetic reinforcement. Geosynthetic are the synthetic materials used in civil and geotechnical engineering to reinforce soil or other geologic materials. Examples include geotextiles, geogrids, and geomembranes. Geosynthetics improve soil stability, prevent erosion, and enhance the performance of retaining walls, embankments, and drainage system. Composite materials. Composite materials consist of two or more distinct materials combined to create a material with improved properties. Reinforcements like fiberglass, carbon fiber, or Kevlar are often embedded in a matrix material such as epoxy or polymer to produce composite materials that offer exceptional strength to weight ratios. Composite materials are used in aerospace, automotive, marine, and other industries. Pre-stressed and post-tension reinforcement. These techniques involve introducing internal stresses to a structure before or after the concrete has cured to counter attack. External loads. Pre-stressed concrete uses tensioned steel tendons to create a compressive force within the concrete, while post-tensioned concrete places tendons under tension after the concrete has hardened. Both methods enhance structural integrity and reduce cracking. Reinforced soil. In geotechnical engineering, soil can be reinforced using various techniques including soil nails, soil anchors, and mechanically stabilized earth (MSE) walls. These methods strengthen the soil ability to resist external forces, making them useful for retaining walls and slope stabilization. In some cases, retaining walls may require reinforcement with geogrid or other materials to enhance. Reinforcement plays a critical role in ensuring safety, longevity, and performance of the structure and infrastructure projects. Engineers carefully design and specify reinforcement materials and method based on the specific requirements and loads associated with each project. Properly implemented reinforcement can significantly enhance the structural and functional characteristics of a wide range of construction materials and systems. Stability, especially for walls with steep slopes or heavy loads, helps in providing tensile support to the structure. Slope stability. Analyze the slope above and below the retaining wall to ensure it is stable and won't erode over time. Safety barriers. Safety barriers in the context of retaining walls are perspective measures or structure designed to enhance the safety of the individual and properly near or around retaining walls. Retaining walls can pose potential hazards, especially in areas where there is the risk of falling, sliding, or collapsing materials. Safety barriers are essential to reduce these risks and prevent accidents. These are some safety barriers commonly used in conjunction with retaining walls. Guardrails. Guardrails are horizontal or vertical barriers installed along the edge of a retaining wall or near its upper structure. They serve as protective barriers to prevent people from accidental falling off the wall. Guardrail can be made of various materials including metal, wood, or concrete, depending on the aesthetic and functional requirements. Handrails. Handrails are similar to guardrails but are primarily designed for providing support and stability to pedestrians using staircases or pathways or adjacent to the retaining wall. Handrails are often required in areas with significant foot traffic to prevent falls. Fencing. Fencing is another commonly safety barrier used in conjunction with the retaining wall. Fencings can be installed along the top of the wall or at the base to restrict access and provide a physical barrier, particularly in the areas where the drop off from the wall could be hazardous. Warning signs and markings. Signage and markings are the crucial for alerting people to the presence of the retaining wall and any associated hazards. Signs can convey important information such as keep off or no trespassing and provide warnings about potential dangers. Second, lighting. Adequate lighting can improve visibility around retaining walls, especially in areas where pedestrian or vehicular traffic is expected during night time. Well-placed lighting can help prevent accidents and enhance overall safety. Safety nets. In some construction or excavation scenarios, safety nets or debris nets may be used to catch falling materials or debris, reducing the risk of injury or property damage below the retaining wall. Tactile paving. Tactile paving consists of textured or patterned surfaces that provide tactile and visual cues to pedestrians, including those with visual impairments, about changes in elevation, such as transition from the retaining wall to a walking surface. Anti-climbing measures. In areas where anti-climbing the retaining wall is a concern, anti-climbing measures such as curved or spiked tops can deter individuals from attempting to scale the wall. The specific safety measures and barriers required for a retaining wall depending on various factors, including the wall height, location, proximity to pedestrian or vehicular traffic, and local safety regulations. It is essential to assess the potential hazards associated with the retaining wall and implement appropriate safety measures to protect people and property. Consulting with a structural engineer or construction safety expert can help ensure that the retaining wall is designed and equipped with the necessary safety features. Safety barriers. If the wall is near a pedestrian or vehicle pathway, install safety barriers or guardrails to prevent accidents. Regular inspection and maintenance. After construction, regularly inspect the retaining wall for signs of damage, erosion, or shifting. Address any issue promptly to prevent further deterioration. Local building codes. Ensure compliance with local building codes and regulation, as they often include specific requirements for retaining wall construction. Professional installation. Hire experienced contractors who specialize in retaining wall construction to ensure that the wall is built correctly and safely. Avoid overloading. Do not overload the retaining wall with excessive weight such as heavy structures, vehicles, or large trees, as this can lead to failure. Safety during construction. Implement safety measures during the construction process, include proper equipment operation, worker training, and adherence to safety protocols. Emergency plan. Have an emergency plan in place in case of wall failure. This includes excavation procedures and a plan for addressing potential damage. Now, if we talk about the general civil engineering, there are various methods which can be used for the safety purposes. Safety is a paramount concern in civil engineering to protect the health and well-being of workers the public and the environment implementing safety measures is essential to prevent accidents, injuries, and damage during construction and maintenance projects. Here are some general safety principles and practices in civil engineering. Number 1. Compliance with regulations. Ensure that the projects adhere to local, national, and international safety regulations, codes, and standards. Stay updated with the changes in safety guidelines and laws. Risk assessment. Conduct through risk assessment before starting any project, identify and potential hazards, and develop strategies to mitigate risks. Third, safety plans. Develop and implement comprehensive site specific safety plans for each project. These plans should outline safety procedures, emergency response plans, and the role and responsibilities of workers and supervisors. Fourth, training and education. Provide appropriate safety training for all workers and ensure they are knowledgeable about safety procedures, equipment, and hazards. These includes regular safety briefings and refresher courses. Number 5. Professional protective equipments PPE. Ensure that all workers have access to and use the necessary PPE such as helmets, gloves, safety glasses, steel-toed boots, and high visibility clothing. Equipment safety. Regularly inspect and maintain construction equipment and machinery to ensure they are in good working order. Follow manufacturer guidelines for safe operations. 7th, fall protection. Install fall protection systems such as guardrails, safety nets, or personal fall arrested systems where there is a risk of worker falling from the heights. Number 8. Traffic control. Implement proper traffic control measures in construction zones to protect both workers and the public. This includes signage, barrier, and designated pedestrian walkways. Excavation safety. When working on excavations, follow safety guidelines for trenching and shoring to prevent cave-ins and protect workers. Number 10. Material handlings. Train workers on safe methods for handling, storing, and transporting construction materials to prevent accidents and injuries. Number 11. Fire safety. Have fire prevention and firefighting equipment readily available on site. Conduct fire drills and ensure workers know how to use fire extinguishers. Number 12. Emergency response. Develop and communicate clear emergency response plan for accidents, fires, and other emergencies. Ensure that all workers are aware of these plans. Number 13. Environmental protection. Minimize the impact of construction activities on the environment by implementing erosion control measures, proper waste disposals, and hazardous material and management. Communication. Promote effective communication among all project stakeholders, including workers, supervisors, and management to address safety concerns and issue promptly. 15th. Continuous monitoring. Regularly inspect the work site to identify and address safety hazards. Encourage workers to report unsafe conditions or behaviors. 16th. Behavior-based safety. Promote a culture of safety where workers take responsibility for their safety and the safety of others, reward safe behaviors, and address unsafe practices. Number 17th. Safety committees. Establish safety committees or designate safety officers responsible for monitoring and improving safety on the construction site. Number 18th. Documentation. Keep detailed record of safety, inspection, incidents, and training to track progress and identify areas for improvement. Number 19th, review and improvement. Periodically review safety performance and incidents to identify areas for improvement, make necessary adjustment to safety protocols and procedures. Remember, the safety is an ongoing process in civil engineering projects. It requires a commitment from everyone involved, from the project managers and the engineers to construction workers and subcontractors, to prioritize safety at all times. Conclusion: safety should be a top priority when designing, building, and maintaining retaining walls to prevent accidents, property damage, and costly repairs. Consulting with a qualified engineer and following best practices with the help ensure the safety and longevity of your retaining wall. Thank you and have a nice day.